Topic 9, Lesson 1. Please follow along on page 222 of your Envision Math book. Remember, you may pause the video at any time to practice the skill I am teaching or to find the page we're working on. Before we begin, it's important to understand the key vocabulary. First, the numerator is the top number of a fraction, while the denominator is the bottom number of the fraction. But the word of the day is going to be equivalent fractions. What are equivalent fractions? Pause the video if you would like time to answer that question. You're right. You listened to the term equivalent and thought equals. Equivalent fractions are two fractions that are equal. Pause the video and see if you can come up with another fraction equal or equivalent to 10 over 15. Exactly. You also could have said 30 over 45, 45 over 60, or even 2 over 3. Using fraction shifts like these make finding equivalent fractions much easier. For example, if we were looking for an equivalent fraction for 1 over 3, how many sixths would we need? Right, we would need 2. So 2 over 6 is equivalent to 1 over 3. One way to find equivalent fractions is to multiply both the numerator and denominator by the same non-zero number. Another way to find equivalent fractions is to divide the numerator and denominator by the same non-zero number. This can be tricky because you need to find a number that can divide evenly into both the numerator and denominator. Can you think of an example for this? Right, 5. If you divide both numbers by 5, you get 2 over 3. Therefore, 2 over 3 is an equivalent fraction to 10 over 15. Let's practice some of this. So please look at the guide to practice on page 222. For questions 1 through 5, it asks us to find two fractions that are equivalent to the fraction given. Number 1 has been started for us. If you multiply both the numerator and the denominator by 2, you get the fraction 4/8. That is one equivalent fraction. Also, if you divide both the numerator and denominator by 2, you get 1 over 2. So that is another equivalent fraction. If you feel comfortable with this, you may want to pause the video, try questions 2 through 5 on your own, and then push play and check your work. If not, follow closely, and at any point, push pause and give it a try on your own. Okay, number 2, 24 over 48. If I multiply both the numerator and the denominator by 2, I get 48 over 96. I can also check to see if there are any any numbers that divide evenly into both the numerator and the denominator. And there is. I'm going to divide both by 4. So my new fraction will be 6 over 12. I also could have gotten 1 over 2, 2 over 4, 8 over 16, or even 12 over 24. For number 3, 10 over 35, I'm going to start at the same spot. I'm going to multiply both numbers by 2 and get 20 over 70. I'm also going to divide both numbers by 5 and get 2 over 7. So I have two numbers that are equivalent fractions, 20 over 70 and 2 over 7. Question number 4, 6 over 10. Again, I'm going to start off by multiplying both numbers by 2, and I get 12 over 20. I also can divide both numbers and get 3 over 5. So both 3 over 5 and 12 over 20 are equivalent fractions. If you've noticed, every time so far that I started off by multiplying the numbers by 2. That will work every time. Finally, question number 5. Right off the bat, I see something interesting. There are not any numbers that I can divide the numerator and denominator by that will come out evenly. So I'll simply start off again by multiplying by 2, and I get 8 over 18. So I found my first equivalent fraction, but now for my second one, I can't divide. So I'm going to have to choose another number to multiply. So I'm just going to take the next one and I'll multiply them by 3. And I get 12 over 27. So my equivalent fractions are 8 over 18 and 12 over 27. And that's how we find equivalent fractions. See you tomorrow.